Okay, so what is the problem with this VCM? It is a common mode voltage. Let V1 is the first input and its gain is A1, and V2 is the second input and its gain is A2. Means if you observe here the two transistors, input is here and output is here, gain is output voltage by input voltage, something like that. So here we have two inputs and it has two gains, A1 and A2. For input V1 we have gain A1, for input V2 we have gain A2. Okay, so overall output voltage that is taken here, this is A1 V1 plus A2 V2. Okay, A1 V1 plus A2 V2 like this, but VD equal to V1 minus V2, differential mode voltage, and common mode voltage is V1 plus V2 by 2, where this is called common mode voltage. Okay, if we apply a common signal to both, the output voltage obtained is a common mode voltage. If we apply some signal between the two input terminals of an operational amplifier, it has a common mode part and differential mode part. Okay, so it should not allow the common mode part, suppress it, and you should amplify the differential part only. That is from these two expressions, substituting V1 and V2 for V0. V0 equal to ADM VD plus ACM VC. So V1, so if you substitute this one, if you solve for these two expressions, you can rewrite in terms of VCM and VD, that is V1 and V2 in terms of VCM and VD like this, and substitute these two in this expression, you will get this one, where ADM is half into A1 minus A2 and ACM is half into A1 plus A2. This is common mode gain, this is differential mode gain. Ideally this should be very less compared to this one. This should be ideally 0. So what is this common mode rejection ratio? Common mode rejection ratio is to reject the common mode input signals is expressed in terms of a common mode rejection ratio, that is the common mode, that is differential mode gain to the common mode gain. Its ratio is known as a CMRR, common mode rejection ratio. For an ideal op amp, this common mode gain is approximately 0, so this ratio become infinity. Okay. Level translator stress. If you have seen here, we don't have any capacitors connected between one level to the next level, that is input stage to the intermediate stage. Okay, as these are manufactured in IC form, we should not connect a capacitor in between one stage to another stage to block the DC level. So this DC is transmitted to this one, and means it will affect the operating point of this stage. So at the output we will get an amplified form of this input signal, but with some shift in DC level. Let us suppose if this is the, if our signal is something like this, the signal is something like this, its DC level is 0 here, and we may get at this stage DC level is somewhat like this. So this is the DC level we will get. Okay. So this is the amplitude. Now this is the amplitude of the signal. Okay. So in order to make this, actually this is 1 volt This may be 10 volt. If you increase it to 10 volt, you will get 20 volt here. Okay. So in order to convert this like this is a 10 volt. Yeah, 10 volt. 10 volt minus 10 volt. So here 1 volt minus 1 volt. So due to this, if there is a capacitor, it will block the DC level, but we don't have capacitor. It doesn't block the DC level, and the operating point of this stage affects, and it may go like this. In order to bring this down to here like this much voltage. So what is this voltage? If this entire thing is 20 means this is 10. Okay, so it should add, this level shifter should add minus 10 volt in order to bring this down like this. That is a function of this level translator. Okay, or level shifter. Okay, so see here, level shifter is usually connected in typical operational amp so as to shift the DC level at the output of the intermediate stage. Okay, so in other words, the DC level raises from one stage to next stage as direct coupling between the two differential stages. This increases the DC level, raise the operating point of the next level. The limit This limit the operating voltage and also causes the distortion in the output. Okay, so it is essential to use this one. Okay, if you are not using this one, what happen? This DC level is directly entered here at the output. So we need amplified version of this input, like this to this, but we will get something like this. This will cause huge distortion at the output. So we have to add some negative voltage to bring down this one like this. Okay. So earlier DC level is here. Now the DC level is here. We are shifting this DC level down to this by using this level shifter. Output stage. The function of this output stage is to supply the load current and to provide a low impedance. Okay, so this is the output stage we find. Okay, a simple output stage is a emitter follower with the complementary transistors as shown in figure. So this is the emitter follower with the complementary transistors. This is PNP, this is NPN. Okay, a complementary pair is there. If Vi is positive, okay, if it is positive means high voltage. If we give high voltage, NPN on. If we give low voltage, PNP on. So this is complementary stage. One is on means another is automatically off. If this is on, let us suppose what happen. So this will open and current flows to the resistor, load resistor like this. Okay. Let's suppose this is off and this is on. What happen? So this will supply some, so current circulates in this mode. Okay, so two supplies are required here, VCC and minus VCC. We hope you understand why minus and plus VCC. So this is required to circulate the current in this direction, this is required to circulate the current in this direction. This is on, this is off, and vice versa. Okay, to supply load current and provide low impedance. Low impedance path will be provided, means it will amplify the swing. Yeah, transistor Q1 off, Q2 acts as a sink to remove the current. Okay, so this will feed the current, this will remove the current, something like this. Feeding means it is in this direction, removing means like this. Okay, open loop frequency response. So for this frequency response curve, we can see that the product of gain against the frequency is constant at any point of the curve.